Hey everyone, today's lab is about developing for mobile platforms. Well, more specifically for Android. Now, I want to start by talking about the differences between iOS and Android development in general. The one thing you need for development on iOS is Xcode running on a Mac. That might have changed actually, but in my memories, that's what it's been like. And I also think that's how it is for the Unity workflow. You need a Mac with Xcode. Without that, you cannot deploy on iOS devices. Deploying actually means taking your build, like your binary, and then just putting it onto your physical device as a file and having that device execute that file. It's much easier to deploy on Android because you don't need any specific software. You don't even need any specific operating systems. So it's much more open and free in that sense. If you do own an iOS device and you want to try out deployment, feel free. What's really great is that the way we're going to develop our test here is not dependent on Android or iOS. It's going to be quite versatile. Actually, what's really great about Unity, as most of you know, when it comes to multi-platform support, is that you can have like one project and just have a few conditions here and there and deploy that to a bunch of different platforms. So one project for many different platforms, including mobile platforms, not just PCs and consoles. So if you have an iOS device, but you don't want to set up the Xcode business and whatnot, or maybe you have an iOS device, but you don't have a Mac computer. You might have just Windows laying around. Well, then don't worry, you can still actually do your tests, because we're going to start up by using an emulator that works on Mac and PC called BlueStacks. It's an Android emulator. If you're not familiar with Android emulators, they're basically like virtual Android devices that allow you to test out your product before deploying it on a physical device, which is recommended because there's some time it takes to push onto your physical device your build. And if you can just run it virtually, it's oftentimes much faster to do your testing and debugging that way. Why use BlueStacks as an emulator? In my opinion, it's the best one for games. It's actually engineered for that in mind. A lot of people play mobile games on their PC and they use BlueStacks. So it has hardware acceleration, meaning that it uses the GPU, so you get a good frame rate and a good experience. A lot of people actually prefer using BlueStacks over their actual physical device because, well, you get a big screen, you can use your GPU, and the experience might end up being better. And all the commands that you would use with touch, well, they get delegated intuitively to your mouse. So that's pretty cool. It's going to allow us to develop in Unity for Android or even for iOS. As I said, multi-platform support is quite simple using Unity. And all the touch commands that we're going to write in Unity, once we build the game and we test it in BlueStacks, we can just use our mouse and that will simulate the finger. So we're going to start there actually. We're going to start by downloading BlueStacks and also doing some setup in Unity. Well, actually, let's start with a setup in Unity since I have this Unity Hub open. Now, I'm here in installs, and we can see all the installed versions of Unity that I have. I can add new ones every 2 weeks or something new coming out, right? 2020.3. Oh, interesting. 2020.3 is now the long-term support. Very cool. Anyways, enough about that. So let's say you already have a Unity version here. You can click on these three dots and you can add modules. So this is a similar panel that you get, similar window that you get when you add a new Unity version right here. Add modules. So modules are add-ons that provide additional build support. So you need a lot of libraries and whatnot to build for every platform. So you have to opt in to these platforms when you're installing a version of Unity. Now, here we see Android build support. If you want to build for iOS, you can also click that. I still recommend like doing the Android build support so you can use BlueStacks. And then after that, you can try the iOS build on your free time if you want to actually deploy it on your physical iOS device if you don't own an Android device. All right, so Android build support, and you can see here there's like an offset because there's an arrow, and that arrow is quite important. Now, I'm going to check this, and I want to make sure that Android SDK and DK tools and OpenJDK are also checked. These things are basically libraries that are going to get downloaded and connected per se to Unity to allow the building of Android. Why do you have to check them? Like, why can you uncheck them? Well, you might actually already have these libraries on your computer somewhere, so you don't want to be redundant and download them once more. Let's say you have like 5 versions of Unity that you're supporting. You don't necessarily want to download these libraries like 5 times either. So you can manually go into the Unity preferences and select the directory where these libraries exist. I don't have them downloaded on this computer right now, so I'm going to keep them checked. And even if you already have them, it might just be more simple to download them again. Yes, it's redundant, as I said, but just for the sake of this lab and doing things quickly, I mean, this is the easiest way to get started, where you don't have to go find the directory yourself and connect it yourself and whatnot. Okay, so I'm going to click next here. And of course, we read all of this, right? There we go, I read everything, and I'm going to check this. I agree to terms and conditions, and now we wait. So I'll see you in a couple of minutes. You will know when the download is finished once you see this Android build support icon. To download BlueStacks, simply write BlueStacks in Google and select the first link, and now we are met with the choice. We can download BlueStacks 5 or BlueStacks 4. 5 is not fully released, as you can see here. It's still in its beta form. BlueStacks 4 is what I'm familiar with, and I know that it runs well, so I'm going to select that. If you want to try version 5, go ahead. I'm pretty convinced it will work just fine, but I really want to be 100% sure that it works for everybody, so that's why I'm going to select BlueStacks 4. Now I'm going to click here, download the file, and open up the installer. I'll see you then. Once you launch the installer, you will see this window, and it allows you to customize the path where you want to install to. By default for me, it's program data and not program files, which is strange, but oh well. And you can actually check accept software license. It's actually pre-checked, which is quite interesting. If you really do want to read the software license, you can click here. It will open up their terms and privacy agreement on their website, which we should read, but nobody will. Okay, and we click on install now. We wait a few minutes for it to download, and I'll see you, well, once I'm done. At the end of your installation process, you might be greeted by this window, Hyper-V Inaccessible. I guess it's about time we talk about virtualization just a little bit. Now, the BlueStacks emulator is an emulator of an Android device, which runs on a different operating system than, well, Windows or Linux or Mac, whatever your computer is in. Let's say that your computer operating system is called the host operating system. If you've ever used something like VirtualBox, for example, that's called a type 2 virtualization, where we have our host operating system, like Windows here, running what we call a hypervisor on top, and from there we run our virtual machines, like our virtual Linux machines or even other versions of Windows. Hyper-V is a Windows-specific technology, which is type 1. So just to reiterate, VirtualBox is a type 2 hypervisor system, and Hyper-V It's Windows specific, and it's a Type 1 hypervisor, which is called bare metal. And I won't go into the details of what's the difference between both of them. Like, I'm not even an expert in this domain, but I just thought it would be interesting that you actually know what you're about to enable here. Because yeah, we need to enable Hyper-V if we want to get the maximum amount of performance, because as I said, it's bare metal, this Type 1 Hyper-V. And bare metal, what does that bring to mind? It makes me think of our hardware. It makes me think of our GPU, more specifically in this case. So using this Hyper-V, I think we get better hardware acceleration. Now, of course, with a Type 2, like with VirtualBox, you can enable graphical acceleration to make, your Linux UIs and your Windows UIs and all these virtual machines quite more fun to use. But I don't recall if they're as performant as this Type 1 bare metal hypervisor. So that's not actually the only thing that we need to consider. When speaking about virtualization, I'm going to open up my task manager and I'm going to go into more details, performance, and we can see here virtualization. Virtualization. I always have a hard time to pronounce that word. Too many syllables. Anyways, it's enabled. So why is this thing saying, hey, Hyper-V is not accessible, let's grant and restart? But here I'm getting conflicting information. Well, it's not the same thing. So you have hardware level virtualization that you activate through your BIOS or BIOS or whatever you want to call it. Or UEFI nowadays, actually. So not legacy BIOS, but UEFI. You can turn on your virtualization through that system, the BIOS or the UEFI. And when I say it's hardware, well, it's processor based. So every modern Intel or AMD processor allows virtualization. So if you're rocking a Ryzen, a gaming CPU and stuff in Intel, don't worry, it should work just fine. But you need this to be enabled. And then you also need Hyper-V to be enabled. So it's a two-layer thing. It's like a processor level, which we're seeing here in the performance window. And then on the Windows level, the operating system level, we want to enable Hyper-V. If this is disabled, well, as I said, we gotta go into the BIOS or the UEFI and enable that. So I'll shoot a quick video on my camera, my phone camera to be more precise, of me activating it. Of course, every UEFI or BIOS is different depending on your motherboard manufacturer, but it should be pretty similar. Okay, so that being said, I'm going to grant and restart. When it's going to restart, I'm going to go into my UEFI or my BIOS. I don't even remember what I have here. And from there, I'll start filming how to change virtualization, how to activate it on the processor level. Okay, I hope that was clear. So let's try that. Okay, so I'm in my UEFI BIOS utility right now. Now, mine is graphical because it's UEFI. If you're using a legacy BIOS, it's going to be text-based, but don't worry, you should still have the option to enable or disable your virtualization on your CPU. Okay. Of course, I'm not going to have necessarily the same graphical interface as you because I'm using an Asus motherboard and you might be using something different like a Gigabyte or whatever. But no matter what, you should always have an advanced mode. I've never seen one of these that does not have an advanced mode. So I'm going to go in advanced mode. And this is where I can start tinkering with a few aspects of my machine. By the way, how did I actually get here? How did I even enter this page? Well, I did the classic trick of restarting my computer and spamming the F12 and delete keys. It's usually one of those two keys, sometimes also F8. It's a way to get into your BIOS before actually booting up your operating system. So yeah, real scientific right there. Just spam your keyboard. Okay, so in advanced mode, I want to find a category that will contain things related to my CPU. So it's not going to be about how I boot my disks. It's not going to be in this weird thing called AI Tweaker. It's going to be in advanced most of the time. And let's see, CPU configuration right there, perfect. Okay, so I get a bunch of information on my CPU. The most relevant one right now is this. So I'm using an Intel CPU, and it's going to tell me, okay, Intel VTX technology supported, great. That means that my CPU, my Intel CPU, supports virtualization. So that's quite important. But as I said before, pretty much any modern CPU will support this. You shouldn't worry about that. What you need to worry about is, well, do I want it enabled? It's not because it's supported that it's necessarily enabled. So if you saw disabled before in your performance tab of the task manager, you want to set this to enabled, and that will fix the problem. And that's pretty much it. Then you can quit and save. So that would depend on your BIOS. Like, I don't even remember how to do this. I'm gonna have to find out how to exit. Oh, here it is. Okay, so exit, save changes and reset, and then we'll reboot back in Windows and carry on. Let's create a new Unity project. And this project is not going to be anything really grandiose. We just want to have a proof of concept where we can build something very simple, like a hello world but for mobile, and have it run in the emulator. Then we're going to try and have it run on a physical device. So if we can get at least that done, we know that we have the foundations for testing and deploying functional. And then, well, we just have to actually create an interesting experience through creating a game or something like that. Now, here in templates, you can see that I have a lot of extra ones. So this is the latest version of Unity Hub, and I believe it has more templates. The ones that are mostly grayed out here are just templates that I have not downloaded. So I do have this mobile 3D one. If you don't have as many items in this list, just wait a couple of seconds. You might see in the lower left corner here something saying about fetching all of these. So I've never really used the mobile 3D or 2D templates. I tried out the 3D real quickly, and by real quickly I mean a couple of seconds, and I didn't notice anything quite interesting about it. So I think just to keep things consistent, we are going to go with either a 3D or the URP. I'm going to go with URP. Okay, and I'm going to name this mobile test, create, and well, you know how long it takes to create Unity projects nowadays, so I'll see you in a couple of seconds. All right, so in our new mobile test project, remember mine is based on URP, so I had a few extra files that I need to clean up for my assets. Also an example assets in the hierarchy that I removed. I deactivated the simple camera controller as well for my main camera, but I'm keeping the post-process volume effects just to see how it looks like on mobile platforms. Okay, so the first thing we want to do is go into File, Build Settings, and select Android for our platform. You are going to click on Android and click on Switch Platform, then wait about 40 to 50 seconds for Unity to do its thing. In the meantime, I'm going to talk about all the other platforms we have here, and I'm going to try and do it in the most polite way that I can. Alright, so we know what PC, Mac, Linux are. Here I'm on Windows currently, so my target platform that I can select is only Windows. If you were on Linux, it would be Linux, and if it was Mac, well, Mac. We know what Android is. We know what iOS is. tvOS, that's Apple TVs. I'm not even convinced that Apple TVs exist because I've never seen one, but I know that they have applications like Netflix. So if you want to create an Apple tvOS app, you could use Unity. Remember that Unity isn't even marketed anymore as a pure game engine. It's more marketed as a real-time development tool. So real-time software development to create real-time applications. Games are one of the things you can create, but not the only thing. PS4, we know what that is. PS5, okay. WebGL, it's a bit more interesting because you can build for web browsers. And this is the most, compatible thing you can create because Chrome, for example, or Firefox family browsers run on every platform, be it Android, iOS, PC, Mac, etc. Of course, you're not going to get the most performance out of your web browser-based game compared to a natively built game, because it uses this WebGL middleware. So you're not calling like native things directly. You're on this more abstract, superficial level in your web browser. So it's basically a virtual machine. You can see like your Chrome-based browser or your Firefox-based browsers as virtual machines, because that's pretty much what they are. It's the reason why Chrome takes so much RAM as well. So you're like building for this virtual machine, which is your browser. And yeah, it's really great because it's cross-compatible. But, just like anything using a virtual machine, it has to call some native code somewhere in the background. And there's a cost to that, which isn't always a big deal. But if you're trying to get like real cool esports gamers, 240 FPS Doritos Mountain Dew games, well, maybe WebGL isn't for you. It is quite cool to create applications, however, right? Once again, not everything needs to be a game. So if you want to create this cool application and you want to have it accessible on a browser, you could use Unity for that. And what else? Okay, Xbox One. More complicated than PS4, PS5, but in a good way. So Xbox One refers to the family of Xbox One consoles. So that's the original Xbox One, and not the original Xbox, but the Xbox One that came out after the Xbox 360. Then it also includes the Xbox One X, so the upgraded 4K version of the Xbox One, and the newer Xboxes from the current generation of consoles, which are impossible to find, but this family Xbox One includes them. So that's the Series S and Series X. All of these consoles are pretty much the same in terms of their architecture and how they run applications and games. So what's really great is that, well, one size fits all. You build for Xbox One and it will run on previous Xboxes and current generation Xboxes just fine. Well, just fine. Of course, the newer ones are more performant because they have better specs, but at least they will launch. Now, if you create a game that's specific for the newer Xboxes and you want to use the newer GPU and CPU and hard drive in those consoles, and then you try and run it on the previous generation of Xboxes, you might not get the same experience because your FPS might be quite low. But, at least it will launch. It will launch. Okay. What's left? Oh boy, UWP. Allow me to rant just a little bit. Does anybody remember the Windows Store? Or I guess a Microsoft Store, I should call it. Now, in typical UWP fashion, the program is not responding. So let's try. Okay, here it is. There we go. So this was heavily pushed in the Windows 8 days, some of the darkest days of Windows history, alongside Windows Vista. And what's the appeal here? Well, let's take a look. This window, just like the settings window in Windows 10, are kind of similar in design. Like the fonts and the shapes of these buttons here. Okay. Because these are UWP programs. And they all have like this distinctive UWP-ness to them. What's so universal about this? Well, remember again, Windows 8 days, you had the Windows Phone, which was supposed to be this big deal. And just like their Zune to compete with iPods, well, that really did not work out well for them, right? But you can compile a UWP app and it will run on all these different flavors of Windows, including Windows Phone, Windows for desktop, also Xbox Ones. If you have like the Netflix app or the weather app on your Xbox One, they're not built the same way. They're built just as like these universal Windows platform programs. So that's great for cross-compatibility between Windows ecosystems. Do people still use this? You still use it when you go into things like settings. Oddly enough, Windows 10 released without migrating all of their forms and settings to UWP. So here we have like classic WPF or WinForms Windows. But I think in a recent update, this has changed, or in the next update for Windows 10, which is coming up soon, I think everything's going to be migrated to UWP. So yeah, Microsoft still invests in UWP, but I can't really see any people developing for it other than them. I haven't seen any UWP apps in so long because everything's about web apps nowadays, or mobile apps, or cross-compatibility between Mac, Linux, PC, Android, iOS, and everything like that, which again is why web-based apps are so popular nowadays. But I mean, it's there if you want to use it. I started out with WPF, Windows Presentation Foundation, which was the successor to WinForms. And the successor to WPF is this UWP thing now. Will there be something after UWP? I don't know. Even Windows seems to be really pushing the web angle and their multi-platform angle with all their promotion for Linux-based stuff. There's also IoT versions of Windows, so Internet of Things, to run on these embedded chips like Raspberry Pis and whatnot. I can't recall if UWP applications run on them, but I think so. Anyways, enough about that. Let's get back to the actual topic. Sorry for my tangent. Now, what we're going to do first is we're going to go in Game and then Free Aspect and select an aspect ratio or resolution appropriate for a mobile device. I'm going to go with 18:9. Now, don't worry if your specific phone is not 18:9. This is just for visualization purpose in the Unity editor. Now, obviously, different phones have different resolutions and aspect ratios, so there are ways to take that into account. You can have your UI scale or move things around depending on the screen resolution, just like with any other desktop application, right? So if you have a 4K screen for a game and somebody else has a 1080p screen, it doesn't mean you need to create two different games for it. You just have some code in the background that will rescale things appropriately for your given resolution. We're not going to go in great detail on how to do that, however, because it's not complicated, but time consuming, and we don't have that much time because you know how slow I am. So let's just get to the good stuff. We're going to add UI canvas to our game objects here. And you can notice that this canvas game object is by default on the UI layer. And what is this game object? Well, it's going to be the parent to a bunch of other UI elements, such as scroll bars, drop-down menus, input fields, panels, buttons, and whatnot. Actually, let's go with button here. So I added a button. And I'm going to just take the button and bring it down a bit. Okay, cool. So how does the canvas really work? Well, one thing that's really interesting is if I take my camera, let's say, and I just move my camera about, right? And we can see that my camera here is not really seeing anything in the environment. It's not even seeing the canvas when I do this. Because by default, the canvas and all elements within it are going to appear on top of the active camera. So here on canvas, we have, well, a component named canvas, which is confusing to have a game object and component named the same thing, but oh well. Here we have render mode, screen space overlay. Okay, so it's going to print the canvas and all the elements in the screen space. So basically you could think of it as on top of our main camera. No matter where our camera is, no matter its orientation, and also no matter like what the camera is seeing in the game environment itself, we're always going to print our canvas on top of that. So let's say I have a cube here, I'm going to put it 0, 0, 0. My main camera, I'm going to move it to a position where I can see the cube. So here it is. And in game, well, I place my button at the bottom of the canvas, so that's where it is here. If I take my camera and I move it around like this, we can always rely on the canvas to print things in the same fashion. So once again, my button is on the bottom here. That's really convenient. What about different resolutions? Once again, here on Canvas Scaler, we have scale with screen size. Now you can see that in my visualization, it kind of changed things a bit. That's because the default reference resolution is this weird 800 by 600 thing. Anyways, you can play around with this, but as I mentioned previously, I don't want to spend too much time. So I'm just going to go with something real simple, not really dynamic, however, but oh well. Actually, one more thing about different aspect ratios and resolutions. When you're placing these elements in your canvas, you can select different anchor points, and that helps a lot. I'm not going to go into detail once more about how this works, but just know it's all there. It's not really complicated. Just, a few minutes of reading the Unity documentation and you should be good to go. Okay. Oh yeah, what's this event system? So I've added that off screen accidentally. I'm just going to remove it. I'm going to talk about it in a few seconds. But what I want to do now is go into game, okay, and start the game. And see that when I bring the mouse on top of the button, I'm not getting any behavior. If I click on it, there's nothing visual as well, no feedback. So now enter the event system. So UI event system, this is needed for all the Unity UI events, such as on hover, on click, and stuff like that for button sliders and whatnot. So now if I go back, okay, and I start this, I can see that when I hover, it gets slightly more gray, and when I click, well, that's quite evident that it's changing colors. Even if we're on the Android build, the mouse still works. So that's good to know. Now, we want something a bit more convincing than just changing the color when we tap or click on the button. Let's have some text appear like hello world. And I'm going to do something real simple for that. Okay, right click here, UI text. Okay, so I have a text game object. We can see that it's in the UI layer. It needs to be a child of the canvas. That's great. And I'm going to change my text here to hello world. I won't take too much time to try and make it pretty and centered and everything. Once again, this is not a design course. I'm just going to move it a bit up like that. Okay, hello world. And I'm going to deactivate it. Okay, deactivate this game object. And now our goal is to click or tap this button and have it toggle the active state of the text. Oops, not that text, but this one. Okay, how do I do that? Well, with a callback that I attach to the button and some code. So here's the code. I created this new, UI component, which is a real lousy name, but oh well. And all it does is take an object to toggle and has this one public void method that does not take any parameters. And it takes the object to toggle and inverts its active state. All right. Now, if I go on my button, in my button, I have a component called button. Once again, these confusing names. And I have this list of callbacks. So on click, if you're familiar with JavaScript, for example, you probably have used on click events many times in the past. All right, so I'm going to add a new callback. So when I click on the button, it's going to launch an event, which will invoke all the attached callbacks to that event. I'm just going to attach one here, and I want this callback to be the function I've written, enable object. So how do we do that? Well, I need to have this script somewhere, this component somewhere on a game object. So I'm just going to create a new empty game object, and I'm going to call it UI manager. UI manager, and I will give it my UI script that I've created. I'm going to feed the text box, or just the plain text, so it's more like a label, actually I should say, into the object to toggle. And now on my button, on the callback list, I'm going to give it my, where is it? Oh, it didn't rename. Come on, UI manager. All right, there it is. Okay. So I'm going to give it my UI manager right here. Then I select a component of the UI manager. Here's UI. And here I have access to all the public void methods that do not take any parameters. And one of them being the enable object. Okay, so let's try that out. And there it is. So we know that this application is working. Now all we have to do is test it on BlueStacks and then test it out on an actual physical Android device. To build our project, we go into File, Build Settings, Build. We give it a name. I'm going to call it Mobile. And see that the type is APK. That stands for Android Package. And save. Now, the building process takes some time, so see you in a few seconds. Once the build is complete, you should see a mobile.apk or whatever you called it. And what we want to do afterwards is open BlueStacks. So I have it already opened up here. And you're going to go to the My Games tab and drag and drop this file. This is like installing an app. And remember, this is an Android emulator, so you know, we have the browser, we have Google Play, and whatnot. Like settings here, it's all there. So here's my new game that I just installed to the emulator. I'm going to click on it. Okay, it has the name Mobile Test. And you might need to wait like about a minute before you see something. But you might also be waiting forever. So during my tests with the latest versions of BlueStacks, I've noticed that it doesn't work for everybody for some reason. Like for me right now, it's actually not working. The last time I used BlueStacks with Unity was during a few lectures I was giving last year, and there have been multiple updates since then. So what have I done to try and fix this problem, if ever you encounter it? Well, I've tried on newer versions, so the one we just installed previously of BlueStacks 4. I tried it on the Hyper-V version. I tried it on the non-Hyper-V version of BlueStacks 4. And I've also tried it on BlueStacks 5, the beta version. And unfortunately, I can't get it to work with any of these newer versions. It might work on your computer, but for me, I'm having an issue. So in case that you're also having an issue here, we can go and get an old version of BlueStacks. So here, BlueStacks previous versions. First link, and when I did this last year, it was about, about this time period, I believe. So we can go and get 4.2, and this version should work quite well. So 4.2, it's going to download that. Okay. Now we are going to be forced to close this BlueStacks program and also uninstall it. So I'm just going to write BlueStacks here, and I'm going to uninstall it. Okay, here it is. Now your version might be called BlueStacks Hyper-V or something like that, or version 5 or whatever. Just uninstall that if it's not working. And then you'll be able to download and install a previous version that works with our Unity packages. Okay. So let me just start the download. Don't mind my very messy desktop. Okay. And now we just wait again, and then we're going to try and do the same thing by launching this previous version of BlueStacks, dragging and dropping our APK, and just running the program in the emulator, and it should work. While that's downloading, I should precise something. if you need to use this previous version, it's not Hyper-V enabled, so you actually need to disable Hyper-V, restart your computer, and then launch the program, BlueStacks 4. How do you turn off Hyper-V? Okay, I'm just gonna write turn on. Okay, there we go, turn Windows features on and off. And you want to uncheck Hyper-V here, but you also need to uncheck this virtual machine platform and this Windows hypervisor platform. So if you disable it, you're going to be forced to restart your computer as usual with Windows, and then you'll be able to launch BlueStacks. Because if you have Hyper-V activated or enabled and you try launching this program once it's finished installing, it's going to complain and it's going to say something about, oh, you got to disable Hyper-V, blah, blah, blah. Okay, so I've got the BlueStacks program open now, and you can notice that it's in portrait mode. That's because I went into the settings here and set display to portrait. That's just because the game we're going to be testing is to be played in this portrait mode. I'm going to go to My Games, and I've already dragged and dropped the package. I'll just do that one more time as a demonstration. Okay. Now we click, we wait, and we hope, and yes, it does work. Made with Unity, there we go. And alright, it's not exactly like in the editor, which makes total sense, because again, the editor time is just a preview. It's not what it's actually going to look like on any device. Again, you need to work a bit with the canvas and like set anchor points for your UI elements. Also use the canvas scaler and other things like that to get a consistent looking thing across different resolutions. But that's not really what we want to concern ourselves with right now. We want to make sure that this button works. So if I click on it, now I'm holding it down and I let go, hey, it works. And this cursor that you're seeing really mimics like your finger. So these are registering as touch events, not as mouse click events, and they're working fine. This confirms that if we test this product on an Android platform and we just click on the button with our finger, it will work. So that's some good news. Let's finally deploy our test application onto a physical Android device. The first thing you need to do is turn on developer options on your phone and then turn on USB debugging. If you've never developed for Android before, you've probably never heard of these things or never activated them in the past. So allow me to show you how to do it. It's quite easy. On your phone, you want to start by going into Settings, About Phone, and then you're going to tap 7 times on the build number. It's quite the esoteric ritual. I mean, it's quite hidden, I guess for security purposes, so it's understandable. But once you do that, you will gain the new developer option in the Advanced section. So you're going to go back to Settings, System, Advanced, and now you have developer options, and you can go on USB debugging section and turn on USB debugging, which will allow our workflow to function. So this will allow us to actually, let's say, see our connected device in Unity and push our build onto the device and install it and finally launch it all in one go. Now, if you're working on Windows, you might need the Google USB driver, which you can download here. If you're on Linux, you also need this. So you can use your package manager to get that. So you would typically write something like Android SDK and do a search for that and find the Android SDK platform tools. I'm running Arch Linux and my package manager is Pacman, but the repos for Ubuntu and Debian, Arch Linux, they should have this as well. It's a really common package. Okay, and on Linux you also need to do one more step for security purposes. So you need to do something with udev, which is basically like your device file system. Now you can do this manually, but not that it's a pain, it just takes more time than using your package manager. So typically you would have these udev rules in your package manager quick installation just to streamline the process. Like here, Android UDEV, I've already installed this package. So if you're working on Windows or Linux and you've done the correct process here, if you go back in your build settings, you should see Run Device Your Phone. Obviously make sure that your phone is connected. If it is and you're still not seeing it, you might need just to refresh. Here I'm detecting my Samsung Galaxy Note 8. If you're on Mac, I'm not so sure about the process because I don't own any Apple products, unfortunately. So I've never been able to test it out, but you might need the ADB Google USB driver. But I'm sure you could quickly find it out. Oh, actually here, if you're developing on Mac OS X or Linux, then you do not need to install the USB driver. Oh, interesting. So it should be simple on Mac OS X. Anyways, I'm going to go back into my build settings and this time build and run. So we're going to build again. That's not different. But at the end of the build now, what it's going to do is, as I mentioned earlier on, it's going to push or transfer via USB our APK, our package, to the run device that's selected. It's going to install it, and then it's going to launch it all in one go. So it should be happening quite soon. I'm going to hold my phone in my hands, and I should see the screen change to run the game. And there it is. Obviously, you can't see it because I'm not recording my phone screen right now. But what I will do just to prove the concept that it's actually working, I'm going to take my very low quality webcam and just attempt to film myself pressing the button in our quick test game. That's it for part 1 of the lab. Just as a quick recap, what we did here is find a workflow. So hopefully you found the correct version of BlueStacks. Maybe the modern versions worked for you. Maybe you had one with Hyper-V. Maybe you tried the beta version and that worked without Hyper-V. Or maybe you needed to roll back to a previous version without Hyper-V, as I showed also, to get it to work. Now that's a bit of a pain, but once you find it, at least we don't have to think about it anymore. And hopefully, if you have an Android device, you were able to put up developer mode, USB debugging, and actually build and push or deploy our test game directly on your physical device, and you could feel for yourself the touch responsiveness working with the buttons.